Ergon Energy has introduced a new standard to ensure that we only place high quality oil into our substation HV plant in a safe and consistent manner. The standard, which is now on the process zone, covers the handling of oil from the receipt from the supplier right through to placing oil into your plant in a substation environment. The standard does not cover any of the sampling of oil that's already covered under your existing maintenance standards. It's also primarily targeted at substation plant. We're not looking out in the distribution world at this point in time. What we want to cover today is looking at the test requirements, and that covers two things: your breakdown voltage testing of your oil, as well as the moisture in the oil. We're also going to look at some of the newer test equipment that we've purchased, as well as some of the new standards that we've put into place for some of our equipment. These procedures have been put together by a group of subject matter experts across Ergon. We believe we've got a good foundation, but it will evolve over time based on input that we get back from the guys in the field. If you've got any issues with anything that you see in this video, you can always give me a call, or Mark Cooper a call in Maryborough, who's had a lot of experience and done a lot of the groundwork in setting up the workshop methodologies, and we'll work through those and take your feedback and develop the process accordingly. Okay, just a little bit on the test standards. It varies through the life cycle of the oil as it goes from the supplier right through to when it goes into HV plant. When we get oil from the supplier, we're requiring at this point in time that oil have a breakdown voltage of greater than 30 kV and less than 30 parts per million. This may change in the near future as we are currently negotiating a new oil contract. So as I say, those criteria may change. If you get oil from the supplier that does not meet the requirements, contact the oil contract manager and he will take action accordingly. The reason why we want to monitor oil from the supplier is obviously we want to make sure that we're getting good quality product from them. We don't want to be spending all of our time filtering and getting oil up to a decent standard in the workshops. We want to be making sure that what we're getting is good value for money. Prior to dispatch of the oil out to the substation's crew, the workshop staff are required to get oil to a minimum breakdown voltage of 65 kV with a moisture level of less than 10 parts per million. Out in the field, before the guys place oil into HV plant, generally speaking, if it's for a complete refill, they need to get that oil to a breakdown voltage of 60 kV. There is no requirement for moisture testing in the field. Slight variation on that: if you're only doing a partial refill, you need only to get that oil to a 50 kV breakdown level. One more thing we have introduced under this process to remember, it is when you have done a complete refill on a circuit breaker or piece of plant, we require you to do a post-fill sample on that. That's to make sure that when you filled up that piece of plant that it didn't have moisture in it or contaminants in it. The criteria for a post-fill test are C3 as per the maintenance acceptance criteria, commonly known as the MAC, or 50 kV, whichever is the greatest of these two. Oil is extremely susceptible to moisture ingress. We can get it any time that your oil is exposed to the air. It's absolutely important that we minimise at all times the exposure of oil to the raw atmosphere, because within a couple of minutes your oil will start to degrade by sucking in moist air. Moisture testing is only required in a workshop environment prior to oil being dispatched to crews. There is no need to test for moisture out in the field.
When testing the moisture using the Vaisala moisture meter, this is how to do it. We've got our manifold fitted with cam locks, so therefore it can be taken away and used somewhere else. For this instance, I've got it set in line with a feed line coming in with the tap, which I then will open. Then open the probe tap and insert the probe into the end. The probe that we're using has a sensor right at the end, which requires a flow of oil past it to get a correct reading. Once it is pushed in, then we just turn our power button on, and it then will give us a reading of our parts per million and our temperature of the oil at that time. Once we have finished getting a reading, we then remove the probe, close the tap, and then shut your main feed off, which has stopped the flow of oil. It then can be uncoupled, which we can then take and use on another set of hoses or anything like that.
Breakdown voltage is basically a measure of the dielectric strength or insulating ability of the oil. For new oil, moisture and dielectric strength go hand in hand. So if you're going to get high moisture levels, the breakdown voltage will decrease. You get low moisture levels, dielectric breakdown voltage will increase. A little bit different for contaminated oil, but our process deals primarily with clean oil handling here.
Before sampling, it's important to set the electrode gap. If the electrode gap isn't set properly, it'll give you a false reading. So it is very important to make sure that the electrode gap in there is set perfectly. The standard that we use for the oil is IEC 60156, which requires a 2.5mm gap between the electrodes. So you put that down between the electrodes, twist your electrodes till it is just grabbing on your spacer. Once that is set, there is 2 locking tabs underneath to lock it in, and then retry just to make sure it hasn't moved. When cleaning, the electrodes should just be washed out with clean oil. Do not use any cloths or solvents or anything like that, just straight clean oil will be sufficient. If cloths are used, they can leave little fibres around the electrodes, which will give you a false reading or a bad result when you are testing with your other results.
When we do a breakdown test on oil, the tester will wind the voltage up and do 6 individual breakdown tests. It will then calculate the average of those and give you a result. There are 2 methods spelled out in the document on how to check the validity of your sample. The easiest way is have a look at the average voltage, and if any of the individual test voltages is more than 15 kV away from that average test voltage, then you have to say that you've got a dodgy sample. This may be caused by a number of things. It could be caused by an air bubble that floats down between the electrodes during test. It could be caused by a bit of a contamination on the electrodes, or maybe even a bit of just general contamination that floats down between the electrodes while the test is being undertaken. If you do get a dodgy sample, discard what you've got at the moment, take another sample and retest. Okay, when it comes to care and maintenance equipment, cleanliness is the key, making sure that everything is always stored in a dry atmosphere. As part of this process, we require that all your test equipment be tested and calibrated on a 12-monthly basis. So that applies both to the oil breakdown testers and the moisture monitors. Oil is so susceptible to contamination, mainly from moisture, so we've got to keep things clean. It's important that you flush your sample bottles with clean oil. When taking oil samples, there are just a few things to remember, depending on where you're taking your sample from.
Once the oil arrives from the supplier, it is important to make sure all the taps are turned off so there is no spillage. The next step is then to screw in your adapters. Depending on what type of tanker you get is depending on what fittings you may need for your manifold. After the adapters have been fitted, you are then right to take your sample, remembering to clean your bottles before you take the sample. Once the sample has been tested and passed, you are then able to fill up your bulk storage. When taking an oil sample from an oil treatment plant, this is how to do it. From your inlet side of your treatment plant, open the tap and disperse some oil, and then flush your bottle, and then fill your bottle up. The oil coming out will be quite hot, which will be about 55 degrees, which is what the treatment plant is set at. Once the sample has been taken, put the lid on and set the oil aside somewhere to cool down.
A couple of things that are important about taking samples from IBCs to remember are that firstly, the sample should be taken at ambient temperature. It's also important that if your oil has settled for some period of time, that it is stirred thoroughly prior to taking your sample, because experience has shown us that oil will actually settle into pockets of different dielectric or breakdown voltage strength over time. So by stirring the oil, we'll get a more accurate value for the average strength of the oil in that IBC.
I'll now do a sample. Just remove the lid. clean the syringe. And then discard the oil. Next, we want to flush our sample bottle. And with any left out oil, give the syringe another clean. With the bottle, we want to put the lid back on and gently roll it around. So therefore, if there are any contaminants in the bottle, it should remove them. And then discard any oil. And taking the sample, gently push down for the oil to go into the bottle, filling the bottle up. And tighten the lid up, that way there should be no air left in your sample bottle. After finished, put the lid back on. Make sure you label the bottle with the number of the IBC and discard any of the oil that you didn't use in the appropriate oil containers.
When you're out in the field, take your sample on the day that you're going to actually install it into the HV plant. The reason being is that oil will degrade somewhat throughout the time that you have it on site. We appreciate that there is still a need to dispatch oil to field staff in containers other than stainless steel IBCs. It's essential that if oil has settled for more than a week, that you stir the oil in both the jerry can or the 205 litre drum prior to taking the sample. I can appreciate that it can be difficult in a 205 litre drum to stir the oil. If that is the case, it becomes essential to take both a top and bottom sample. If either of those samples fail, the oil must be either treated on site to bring it up to standard or returned back to the workshops for further treatment. Once you've obtained a good test result from your sample, before you pump new oil into plant and equipment, make sure that your pumps and hoses are adequately flushed with clean oil.
To do this, just lift your line up just a touch and keep an eye out till the oil is clear. Depending on the length and the size of your lines will determine how much oil that will be need to pump through till the lines are clear. If in doubt, pump it a little bit more out. It's better pumping more out than not pumping out enough.
And finally, just a few more things to be aware of that are in the standard. We'll be dispatching oil out to the sub-operations staff in stainless steel IBCs. We've migrated away from PVC IBCs for two main reasons. One, we found PVC IBCs are really susceptible to sweating, condensation, which significantly affects the breakdown voltage of the oil. And secondly, just from an environmental perspective, they are more susceptible to damage. If we can maintain or get oil at a high quality, probably the best thing we can do is put a blanket of nitrogen over the oil. Nitrogen equals no moisture. That means if we can get our oil at a high level, put a nice blanket of nitrogen over there, we should be able to maintain that oil at that really high level for extended periods of time. We have two types of pumps used for the handling of oil within Ergon. Firstly, the positive displacement pump, commonly known as a gear pump. The second one is a rotodynamic pump, a centrifugal or a flexible impeller pump. In the event that somebody accidentally shuts off the valve on a positive displacement pump, the pressures can theoretically build up to very dangerous values. Part of this process, we are now requiring that pressure release devices be fitted to all positive displacement pumps, and the operating value of these must be less than 100 psi, and they must be tested and calibrated on a 12-monthly basis. To help with some of the problems we are seeing in the field with maintaining oil quality, we are currently trialling field treatment units in Mackay, Rockhampton and Maryborough. These portable trolley units can achieve flow rates of up to 1,000 litres per hour and are fitted with two separate cartridges, one to remove dissolved water to less than 10 parts per million, and the second for the removal of both particles and emulsified water. Initial reports from Mackay in relation to work on the HLC circuit breakers are promising. As the trials progress, we'll keep everyone up to date.